All right, so the plan today, we're going to get just a little start into factoring, which is what we'll be doing a good chunk of when we get back. But I figured we'll get a little start on it so we have kind of a bit of a background. Now, I don't know how much of this you've done in the past. So I'm just taking notes on the back of the worksheet here, but you can do it on paper or whatever. What we're going to be talking about here is we're going to talk about factoring quadratics. And what factoring is basically taking the quadratic and getting it into what we call factored form, or we might call expanded form. And so you're going to see what we're talking about here as we get into this. So basically what you're going to look at here is you're looking for one of two things. So when we're talking quadratics, we're talking our y equals ax squared plus bx plus c. So the first thing you're going to look for is a equal to 1? Or is a not equal to 1? Now, a equals 1 is the easiest scenario. When a equals 1, what you're going to do, the steps are actually very simple. You're going to take factors of c that add to b. That's what we're going to look for. So we're going to look at factors of this c number. We're going to find a pair of factors of c that add to this b number, and we're going to use those to write the factored form. So I'll give you an example here. So let's say you had the problem x squared minus 5x minus 14. All right, so if we're looking at that as our problem, we'd look at our c value there. Our c value is negative 14. Okay, so factors of negative 14. If you were just to make a list, you'd be like, okay, I know I could do like negative 1 times 14, and I could do 1 times negative 14, and negative 2 times 7, and 2 times negative 7, and that would be it. Okay, so some numbers are going to have a lot of factors. Some don't have too many pairs. Those are all your pairs of factors of negative 14. Now you want to pick I think I said it, but I didn't write it. The factors of c that add to b. Sorry about that. So now you look at your different sets of factors here, and you'll find the pair that adds to give you a negative 5, which is going to be pretty obvious. So like this pair adds to negative 5. That adds to a positive 5. That's negative 13, positive 13. So pick the pair that adds up to your b value. And then once you've got that, to write the factored form, these are going to be the two numbers we use as our factors. So the factored form of this is just going to be x plus 2 and x minus 7. And that's actually the entire answer. So you're finding these numbers by using this little rule right here. So now if you were to work, so like this is the answer. This is the factored form of that polynomial. Now if you ever want to check any of these, they're really easy to check. You just do your distributive property. So like if we did x times x, that's x squared. That's going to be a minus 7x. That's going to be a plus 2x. And that's going to be a minus 14. And you can see, yep, those add to minus 5x. Boom, boom, boom. And that matches what we had. So this is what's called factored form. We're going to use this a ton when we get back from break. Just to show you another quick example of this. Let's say you had x squared minus 16x plus 63. So you just jump right into, all right, my a is 1, sweet. So what's my c value? It's 63. And what are my factors of 63? Well, it doesn't have a ton. It's like 1 and 63, negative 1 and negative 63. See, 2 doesn't go into it. 3 doesn't, 4, 5. So I think it's just 7 and 9 is our other one. So 7 and 9 or negative 7, negative 9. And as you do a lot of these, you're going to probably get to where you don't have to write these out and you can just think of them. But again, we want the pair that adds to negative 16. So pretty obviously not those. That's 64. That's negative 64. That's positive 16. Close to what we want, but not quite. This one is negative 16. So now your factored form is just going to be right here, x minus 7 and x minus 9. And there we go. So whatever numbers you're picking here, you're just going to write those right in as x plus or minus, whatever this is, and x with that one. So that part actually usually pretty easy. Now that's when a is 1. When a is 1, you should be able to crank them out pretty quick. When a is not 1, that's when it's not as cool. So when a is not 1, you're going to do basically two things. For one, you're going to check and see, can you factor out a GCF? So we talked about that briefly in the warm-up. If there's a GCF, sometimes you can factor that GCF out, and then it becomes an a equals 1. And then it's pretty easy to do after that. So that's step 1. And then step 2, if you factor out a GCF and a is still not equal to 1, then we're going to factor by grouping. And I'll show you what that means. So then factor by grouping. And that's what I generally call kind of worst case scenario. But okay, so let's look at an example of this. So let's say we went with with this one. We'll call this just example 3. Sorry, it's probably confusing, but whatever. Okay, so it's not a step. Let's do that. Sorry. Okay, so third example. The idea here, let's say we had this problem. 7x squared minus 45x minus 28. Okay, so we'd look at this, we'd be like, oh crap, A's not 1. So we go down this branch. We say, okay, can we factor out a GCF? Absolutely. If you look at these, every one of these is divisible by 7. So once I do that, I'm going to have x squared. If you divide that by 7, you get a negative 9. And divide that by 7, you're going to get a negative 4. Okay, cool. So now we're looking at that, and we're like, all right, let's see if I can factor what's in here further. Because this is now just an A equals 1. And I'm going to look at it, I'm going to say, are there factors of C that add to B? So can I come up with any factors of negative 4 that add to negative 9? And if you're thinking about this, you're probably thinking, well, it's probably not going to work. Because factors of negative 4 are, like 1 and negative 4, negative 1 and 4, 2 and negative 2. Those are really only combinations. I mean, negative 2 and 2, but that's the same thing. But none of these add to negative 9, which is fine. This is going to happen sometimes too. This actually happened in the warm-up also. So we had a problem that doesn't factor any further. So at this point, that is as factored as this can possibly get, because there is no value, there is no C value that adds to B. So that's it, we're done, okay? So this is kind of like saying this part here is not factorable. Okay, we got a GCF out, that was cool, and that's as far as we could go with it. All right, so sometimes that's gonna happen. All right, let's look at one more example, then I'll kind of have you try these. And I'll tell you, you're not gonna be the master of factoring in this one day. This is just a little start so that when we get back, you've got kind of a feel of it. And you're gonna get way better at this as you practice it. So, if you can do every problem today, sweet. But I don't expect you to be able to do every single problem today. Just make sure you're clear on that. Do the best you can, see what you can figure out so that when we start up back on Monday, a week, 2 weeks, or a week and 10 days from now, whatever it is, that you've got kind of a good just base of factoring. You got a clue as to what we're trying to do. All right, so let's say this was your problem. Let's say it was 2b squared plus 17b. And I'm using b, but the variable doesn't matter. It could be x, y, q, whatever. All right, so let's say that's your problem. First thing, we're like, all right, A is not 1. Can I factor a GCF out? So 2 divides out of this, but not out of either of those. So no GCF. So now we're going to do this thing called factoring by grouping. So here's how this works. Factoring by grouping, instead of just taking the C value, since A is not 1, A is 2 in this case, we actually have to do factors of AC. So we have to do A times C. So 2 times 21 is 42. So all this really changes is instead of using just C, you have to use AC because A is not 1 anymore. So this is kind of the shortcut, the method that you're going to roll with this. So, all right, so now we want to find factors of 42, and we need to find the pair that adds to 17. Okay, so, 1 and 42. I'm not going to bother listing the negative pairs because I know I'm not going to need them here. So then we could do, 2 and 21. That would add to 23. 3 and 14. And at this point, I'm going to stop because I know that that's the one, because 3 and 14 multiplies to 42, but also adds to 17. So as you do these, you're going to get to the point where you may not need to just keep listing these out. You'll be like, okay, I found the right pair. Now, here's the sad part. You can't just write b plus 3 and b plus 14, because if you do that, that's not going to get you this lead term. If you distribute that out, you're just going to get b squared. You're not going to get 2b squared. So this is what we call the grouping part. So here's how this goes. So what you do is you rewrite the problem, except instead of writing this as 17b, you write it as these two factors. So we're going to call it plus 3b and plus 14b. So we're grouping those. We're taking this 17b and we're splitting it into a different group. So this is the same thing. Those would add to 17b. We're rewriting it with these numbers that we chose. And now what we do is we group the first two and the last two together. What do you do from there? You factor the GCFs out of each of those. So at this point, you want to take the GCF out of this. You want to take the GCF out of this. So if you look at these two, GCF, there's no number that goes out of both these besides 1, but we can take a b out of both. So if we factor a b out of here, we're left with 2b and we're left with plus 3. Okay, cool. Repeat the same thing over here. What GCF can we take out of this? Looks like we can take a 7 out of those, but no variable. So I'm going to keep this plus sign here. I'm going to take a 7 out of these, which is going to leave me with 2b. And divide 7 out of that, it's going to leave me with 3. Now, if you've done this correctly, a cool thing should happen. And these parts in the parentheses should match. If you see that, that means you're on the right track and you've done the right thing. If these don't match at this point, then you didn't factor out the GCF. All right, so where do we go from here? Our final answer is, since both these match, we can put this b plus 7 together, kind of like undoing the distributive property. And this is actually going to get us right to our answer. So whatever's in front of these two parts, we're going to turn that into a single factor. So the b and the plus 7, those come together to make one factor, and the 2b plus 3 comes together to make our other factor. And that's going to be our answer. So you have to add this little extra grouping step in there. It's not terrible. You'll get really good at it as you do a bunch of these. But that's the process when A is not 1. Now, with any of these, you can always check them. If you're never sure, do your distributive property and see, do I get this original problem? So b times 2b is 2b squared. B times 3 would be 3b. 7 times 2b would be 14b. And then 7 times 3 is 21. And so you can see, yep, those are going to combine to be 17b. And yeah, that does match up. So I know my factored form is right. All right. So that's what we got. This is actually everything you need to be able to do the worksheet today. Some are going to be way easier than others. Anytime A is 1, you're probably going to crank right through those. When A is not 1, look for a GCF. Once you've taken a GCF out, if A is still not 1, then factor it by grouping. So try this out, see how it goes, and then we'll kind of pick things back up when we come back in 10 days.